Assalamualaikum and hello everyone. My name is Muhammad Irfan Afiq bin Muhammad Nur Ismail and my text number is 2158552, and in this video I will solve the question from digital signal processing quiz. So I will break down each part, explain my thought process clearly and demonstrate all calculations. So let's get started. So for the question 1a, so we need to find the DTFT of the sample signal. The given signal is xt 20 exponential minus 0.1t ut, and the sample at fs frequency is 10 Hz. So for your information, ut is a unit step function. So next we will write the sample signal, which is xn equals to xt t equals to nts. So this is a simple sample period ts of 1 over fs negative equals to 0.1 second. So the sample, so next, so the xn equals to 20 exponential negative 0.1 and 0.1. We will multiply the 0.1 and 0.1, so we got the 20 exponential negative 0.01 n. So we will use the DTFT expression of formula, which is x exponential j omega summation of infinite n equals negative infinite. So xn exponential negative j omega n. So we will substitute all the signal given to the equation, which is substitute xn by x exponential j omega equals to summation of infinite and equals negative infinite. So we substitute 20 exponential negative 0.01 n and also the multiply negative exponential negative j omega n. After that, we will factorizing the equation, which is x exponential j omega equals to 20 summation of infinite n equals to 0. So exponent in bracket exponent 0.01 exponent negative j omega. So this is I will write the geometric series where the sum is valid if modulus r less than 1. So summation of infinite n equals to 0, r to the power of n 1 over 1 negative r. So where r is equal to exponent negative 0.01 and exponent negative j omega. So x exponent j omega equals to 20 over 1 minus e to the power of negative 0.01 e negative j omega. So this is the final answer for the A. So next question B is find the sample signal xn for n equals to 0, 1, 2 and 3. So from the xn, we got 20 exponent to the power of negative 0.01 n. We will substitute the n in term the n for n 0 x 0 equals to 20. Actually I'm taking the 2 decimal point. 20 exponent negative 0.01 multiplied by 0 is 20.00. For n equals to 1, x 1 equals to 20 exponent negative 0.01 multiplied by 1. So in sequence, in order, we substitute the n till the 3. So this is the final result we got for question 1b. Alright, so for the next question, C. If xk represent a 4-point DFT of the xn, find the value of x3. What is the assumption made to the xn when DFT is performed? So first of all, we recall the xn again, which is 20 x 20 90.80, 90.61 and 90.41. We record the xn because we want to know for using the for the value. So we will using the DFT formula, which is x k equals to summation of 3, because we want to find the x3. I'm sorry. N equals to 0. Alright, so xn exponential to the power of negative j 2 pi over 4 kn. So for k equals to 3, because we want to find the value of x3. So then we write the equation like we substitute using the FT formula, which is x3 x0 exponent to the power of negative j 2 pi 6 pi, because 4 0 multiplied by 0 plus x1 exponent negative j 6 pi over 4 1 plus x2 exponent to the power of negative j 6 pi over 4 2 multiplied by 2 plus x3 exponent to the power of negative j 6 pi over 4 multiplied by 3. So the answer we got is, but first of all, we simplify each term that we got from the equation. First one is e exponent negative j 6 pi 4 0 multiplied by 0, we got 1, and the other one is got negative j exponent negative j 6 pi 4 over 4 multiplied by 2, we got negative 1 exponent negative j 6 pi over 4 multiplied by 3, we got j. So after that, we will substitute the sample value. Okay, we substitute the x and so why we will substitute, because you already simplified the each term. x3 equals to 20.00 multiplied by 1 plus 90.80 multiplied by negative j, plus, and then we plus 90.61 multiplied by negative 1 plus 90.41 multiplied by j. So these are the terms, and then the final answer, we will use the real part and imaginary part. We will write we group the real part and imaginary. So the real part is 20.00 minus 90.61 equal to 0.39. So imaginary part is equals to negative 90.80 plus 90.41 negative 0.39. So Thus, the final answer is x3 equals to 0.39 minus 0.39j. So this is the final answer for the question 1c. So the assumption that we got is xn is periodic because it's periodic with a period of 4. So that's it for the question C. Alright, so we're going to question 2. Question 2, given a discrete time linear time invariant system as below. So 2yn equals to xn plus 1 over 4 yn minus 1. First question A, find the impulse response Hn. So we rewrite the equation 2yn xn plus 1 over 4 yn minus 1. So what we need to do is we rewrite the system equation in standard form. So we divide all of them by 2, and then it give us 1 yn equals to 1 over 2 xn plus 1 over 8 yn minus 1. After that, we apply a z transform to both sides, assuming the zero initial condition. So it gives us yz equals to 1 over 2 xz plus 1 over 8z to the power of negative 1 yz. After that, we rearrange to solve for Hz. The given formula for the z transform is Hz equals to yz over divided by xz. It gives us yz equals to 1 over 1 minus 1 over 8 z to the power of negative 1 equals to 1 over 2 xz. So we come to the formula, which is as xz equals to yz over xz. We got equals to 1 over 2. We put the yz and xz into the equation. 1 minus 1 over 8 z to the power of negative 1. Next is we express Hz in a form suitable for finding the impulse response. So we got Hz equals to 1 over 2 summation of infinite to n equal 0, 1 over 8 to the power of n, z to the power of negative n. To that, we use the inverse z transform. So it gives Hn equals to 1 over 2 1 over 8 to the power of n un. So it's for n greater than 0. So that is the answer for question A, finding the impulse response Hn. Next question is B. If an input signal xn equals 2 over 3 to the power of n un is fed into the system, find the system output in both frequency and time domain. So the system output for xn is 2 over 3 to the power of n un. So first we find the time domain first, and then for the frequency domain. We want to find the output yn equals to xn convolution of xn, which is the convolution of xn and hn. After that, for the formula given by yn equals to summation of nk equals to 0 hk xn minus k. So this is the formula that we use for finding the output of time domain and frequency domain. So first, we need to substitute the hk equals to 1 over 2 divided by 1 over 8 to the power of k, and x n minus k equals to 2 over 3 to the power of n minus k. So it gives yn equals to summation of n, k equals to 0, 1 over 2, 1 over 8 to the power of k, 2 over 3, and to the power of n minus k. After that, we factor out the constant, which give yn equals to 1 over 2 multiplied by 2 over 3 to the power of n, summation of n k equals 0, 1 over 12 to the power of k. So next is we summation the equation given. So the summation is a geometric series, so we got n summation of k equals to 0, 1 over 12 and to the power of k. So the answer is equal to 1 minus 1 over 12 to the power of n plus 1 over divide by 1 minus 1 over 12, and then it equals to 12 over 11 multiplied by 1 minus 1 over 12 to the power of n plus 1. We will substituting the result of the series. So yn equals to 6 over 11 multiplied by 2 over 3 to the power of n bracket 1 minus 1 over 12 to the power of n plus 1. So that is the answer for question B for the time domain solution. So next, we need to find the frequency domain. First, the z transform of hz was found in part A is hz equals to 1 over 2 divided by 1 minus 1 over 8 z to the power of negative 1. Second, using the z transform of xn equals to 2 over 3 to the power of n un is xz equals to 1 divided by 1 minus 2 over 3 z to the power of negative 1. So final is the output in the z domain is from the formula of the z transform for the z domain is yz equals to hz x multiplied by xz equals to, you got the answer, 1 over 2 divided by 1 minus 1 over 8 z to the power of negative 1 multiplied by 1 over 1 minus 2 over 3 z to the power of negative 1. That is the answer for question to find the frequency domain, or for the question 2b. That concludes my solution for the SP quiz question. I hope this step-by-step explanation clarify the concept and approach. So thank you for watching.